Hello, my name is Cody and I work for StormForge. Today I'm going to demonstrate to you how easy it is to get started with optimizing your Kubernetes workloads for your online shopping space or e-commerce website. Now before we get started, there are a few things you'll need to do in preparation. First, you'll need to head to app.stormforge.io and create an account. Next, you'll need to head to app.stormforger.com and create an account and an organization there. After that, you'll need to install the Google Cloud Platform microservices demo on your Kubernetes cluster. You can find that demonstration and install instructions at github.com/Google Cloud Platform/microservices-demo. After that's all set up, that should give you an online boutique that looks like this. Everybody knows it as the hipster boutique. And lastly, you can pull up the install instructions to get the both CLIs installed, one for StormForge and one for Forge CLI. Next, what we'll need to do is we will need to install the CLIs and authenticate. Because I'm on a Mac OS, I can simply use brew install. If you're running on a different platform, you can reference the docs on our website to get the binary for your platform installed correctly. Now we are going to authenticate with those CLIs using the account credentials we created earlier in the previous steps. This is opening a login browser. You can also copy the link there and authenticate in that way. Okay, and we do Forge login. Perfect. Now we can verify that we are connected to, can speak to the API by doing forge ping, StormForge ping, and forge ping. Great. Now moving back to our hipster boutique, with our product, you can easily record a HAR file, import that as a load test or test case into our performance testing platform, and use that as a load test in order to optimize various components of your Kubernetes application. So in order to do that, we're going to open developer tools here. We're going to make sure that preserve log is checked, and we are going to reload the website as if a user has just come onto the website. And what we're going to do is we're going to add a few products to the shopping cart. So I'd like some sunglasses, put some sunglasses there, and we'll continue shopping. And I don't know, I kind of like loafers, I suppose. Add the cart there. Perfect. And now let's go ahead and place this order. Perfect. And we're done with that. So what you can do, or what we're going to do here, is we're going to right click on this section right here where all the requests came in, and we're going to copy, and we're going to copy all as HAR because we do not necessarily want all the content. In your favorite flat text file editor, let me see if I can open mine here. What I'm going to do, I know you can't see this, but what I am doing is I am creating a file just named har.txt. And I am pasting that capture there, and I'm saving it as a flat text file. Now what I want to do is I want to go to the Forge app.stormforger.com website, go to the HAR converter, and we are going to select that file and drop it there. You can see it importing. It says, hey, it's good. Now, if you have a lot of third-party cookies and third-party assets that are coming across, we can exclude those, and those will actually be listed here. You'll be able to see those. In this case, to kind of just simplify things, we're not going to go over exporting or capturing session IDs and reusing those, although you can reference the documentation to do that. But for this case, I'm just going to demonstrate how easy it is to come in, import a HAR, and use that as your scaffolding for a load test. We want to filter all the noise out. I'm only want to select the host, which should be excluded, but because we only have one here, I'm going to use that. You can see what was a 11,000 line HAR file has now just been reduced to 113 lines. You can see where I came in and I loaded the website, I got the product, I posted that product to my cart, I got the next product, I went to the website, got the next product here, posted that to the cart, viewed the cart, and then posted I want to check out, my payment information, etc. From here, we're going to create a new test case. You're going to want to name your test case. I'm going to name mine Cody's Hipster Boutique. And I'm going to save this test case. Moving back to the terminal, what we want to do now is we want to generate an experiment that the machine learning will use to iterate through various settings, learn more about your application, and suggest values based on the parameters you defined that you want to optimize for or with. Now, in order to do that, the first thing that we want to do is we want to label the various components that we want to optimize. If we look here, you can see in this demo that there are many microservice components to this Hipster Boutique. Because we only added a few things to the cart, ran through a checkout, there's really only a few components here that I want to test. I'm going to test the cart service, I'm going to test the checkout service, and I'm going to test the front end. For experiment generation to run smoothly, we want to label these components with a unique ID so that when the experiment generates, we only grab those resources from those specific deployments. If I do a hit deploy, I'm going to do OK, edit, deploy, cart service, checkout service, and front end. I'm going to add some labels here. And that should be it. Perfect. Now what we want to do is we want to run the StormForge run command. This automates the experiment generation and saves you a lot of time. It's asking where we want to get the load test from. We created the load test previously, and it shows up here. And my application is running in a default namespace. Next, it's going to ask for labels to match against. These are the ones that we configured earlier in the deployments. And it wants to discover the memory and CPU parameters. We give it that same label. Here, you could also specify if you want the machine learning to run through various replica settings. For this purposes of this demonstration, we're going to bypass this. And the objectives we want to optimize. Here, we're going to do cost versus P95 latency. And you can see that it discovered those resources. And we just want to save the experiment file at this time to disk. You could run it from here, or you could just inspect it, but we're going to inspect it in the next section. Okay, so let's check out this experiment. Now, just for transparency's sake, I went through and went ahead and changed the name of my experiment. As part of the experiment generation process, it gives it a name based on the namespace it's running in, and then appends a unique identifier at the end, and it's just ugly. So I went ahead and changed my experiment name. And as part of the experiment spec, you can see the parameters that the experiment generation located when we generated the experiment. The baseline is your current running configuration, so that when we kick off the machine learning, we measure against your default settings, and the machine learning can get an idea of how your application is performing using those settings. Below that, we have the metrics defined. These are the ones that we selected earlier as part of that experiment generation process. And then we have the patches. So what we're going to patch, we're doing the cart service deployment, the checkout service deployment, and the front end deployment. We can patch other configs or other objects, Kubernetes objects, such as stateful sets, config maps, etc. And below that, you have the trial template. Now, during the machine learning experimentation, we run through and iterate through sets of trials. So each trial will kick off a load test and a Prometheus instance. At the end of that load test, those metrics will get pushed to the Prometheus push gateway. We will scrape those metrics. We will tear down Prometheus. The machine learning will suggest a new set of parameters. We'll patch those deployments and start the process over again and iterate through that. Something to note is that our max number of trials per experiment is 400. The minimum number that we suggest is 20 trials per parameter. That'll give the machine learning a good idea of how your application performs, and you'll see some decent results from that. However, the more you allow the machine learning to iterate through these trials, the better tuning and better target you'll hit for your objective. So let's go ahead and kick this experiment off. And it's created the objects for the experiment. We can do a kubectl get experiments, trials, pods. And you can see it's setting up this first trial we call 000 for the baseline. And if we look at our browser and app.stormforger, and go to your test cases, and go to test runs. You can see I've been playing with this a bit earlier. When this says stabilized and running, we should see the test case and load test kick off over here. Let's just refresh. And you can see this load test is running. so we know that it's working correctly. And if we go back to our terminal, you can see that the create has completed. It's kicked off that job. If you were to look at the logs on this pod, you'll get a good bit of information from that. Just a troubleshooting note, if any of this fails, you can look and view the logs on these objects and the objects of the logs of the controller in the StormForge system namespace to kind of get an idea of what's going on. So what we'll do is we'll let this run, and then we'll come back and view the results. So let's take a look at the results. Each one of these green dots represents a trial that was ran. The machine learning has gone ahead and highlighted a few of what it believes to be optimal settings that are notated by this diamond right here. What we're not seeing is the baseline, and that is that trial 0 that we ran at the beginning. That is because actually the recommended setting, let me just click one of these, the recommended setting is actually our baseline. So we get that validation that our running configuration and the environment we have is the optimal configuration for the objectives that we're trying to optimize for. In this case, you have a low cost and your latency is about 150 milliseconds. Now, you could get just a little bit better performance by choosing this configuration, but it comes at a higher cost. And if we look down here, you'll see the settings for those, and it's letting you know, hey, you're going to have a 44, 45, 46% increase in cost, and with only a 1% gain in performance. So you have to really decide what your objectives are, and if you wanted to choose this configuration right here, you can come over here to export and then copy that out and apply that to your environment. So in the previous example, we applied load with about 1,500 clients. So what I did was I went and increased, just to give you an idea of when applying production-like load, the actual cost savings or performance increases you can actually gain through machine learning. So here what I've done is I've increased the load to about 22,500 clients over a 5-minute period. And as you can see, the recommended trial shows a 72% increase in performance, but with a 51% increase in cost. Now, you don't have to do that. You can select one of these down here, like I select trial 7, and you can see that I actually, for 10% less cost, I can increase performance by 34%. And that's it for this demo. If you have any questions, you can always reach out to us on our public Slack, that is stormforge.slack.com, or you can send us an email. We'd be glad to get back to you and talk to you. Thank you.